So in the previous lesson, we talked about the idea of a stack, and it's an abstract data structure that maintains a set of data, a collection of data, by following a certain set of rules. That idea of LIFO, last in, first out, which always meant that the last item put on the stack was the first item to come off the stack. Today we're going to extend that idea to a new abstract data structure called a queue. Now let me put my marker on here. So a queue, spelt Q-U-E-U-E, okay? You've probably heard this term before. It's the term that British people use to line up, because that's all a queue is. It's a line up. So basically, how does a lineup work? Well, when you walk into a line, you progress towards the front of the line. The person at the front of the line is the next person to be served. So if you're standing at McDonald's, you stand in that line and you wait your turn. When it's your turn and you're at the front of the line, you go to the cashier, and the person behind you then takes your spot as the front of the line. And that's all a queue does. So instead of the idea of LIFO order, it uses something called FIFO. So FIFO is first in, first out. So the first one in the line. So with a stack, we visualized it as a vertical structure like this, where the top of the stack was always the next element in the array. Great. With a queue, we don't work like this. A queue we visualize on its side, because that's the way we line up. At least that's how we typically think about it. So with a queue, the front element is always at element 0. 3, 4, so the front is always at element 0. So whenever we add a new item to the queue, it's just like a real lineup. A lineup that doesn't allow line hopping, which means you always got to come in the back and work your way towards the front to the next available index, which might be right here, for example, right? So it depends on what's actually stored in your queue. So let's think about a few real-world examples. Obviously, I just mentioned McDonald's. Anything lit with that first come, first serve label behind it. So it might be like bobblehead day at the Jays game. So the first 10,000 people that show up get a bobblehead. So you have to be within that queue of 10,000 people to actually get it. Any form of shared resource. So what I'm talking about like that is like a printer inside of a classroom. There may only be one printer for every student. And if everybody hits print, well, the print job that comes next was the first student that hit print. And then the second one would be the next student, and so on and so forth. So any form of lineup, like if you're at Canada's Wireland, you're waiting to get on a roller coaster, you're stuck in that line. And it moves at a certain pace, whatever that pace is, right? Video games. Oh, video games is a big one. So especially in games like artificial intelligence-based games like The Sims or something like that, where the AI basically lives their life. But their life is really just a sequence of events. Each one is the next item in the queue. So if we were talking about this, the first item in the queue might be to wake up. The second item in the queue might be to go brush your teeth. The third item in the queue might be to eat breakfast. And it's just the sequence of items in this queue that every time that the AI does one, it gets removed from the front of the queue and the next one gets shoved up to the active slot, the front of the queue, right? So that's one form of application. Another video game application of queues is in real-time simulation games like Command and Conquer, and even other games where any type of game where you're building units and you have to do resource management, things like that. So for example, a tower defense game. Big time in tower defense. You have to collect your resources so you can build your towers. Once you build your towers can start to build other things. So for example, you might have one tower that builds soldier units and another one that builds vehicles. So you might say, okay, for my vehicle tower, I want you to build the following items. Build a Jeep, build a Jeep, build a tank, build a tank, build a tank, build a Jeep, build a tank, in that order. So you've set up a queue of build operations, and it's going to do them one at a time and then remove them from the queue. So that is what really embodies the idea of a queue. In the next video, we're going to talk about the operations that a queue represents.